Hello everyone. Today, my name is Sandhiraman, and I'm going to discuss with you about the my presentation on the seminar, which is Advanced Encryption and Decryption using Machine Learning Optimization and diverse cryptographical techniques. So let's start with what is the main topic. What is cryptography? It is a process of hiding or coding information that only a person or message it was intended for can read it. And it has been used to code message for thousands of years and also used today. And it's a very advanced version from the past, which we are using now. The modern cryptography techniques include algorithms, ciphers that includes encryption and decryption of information, such as 128-bit to 56-bit encryption keys. Now, let me tell you about the types of cryptographical algorithms, in which some of them are steam ciphers, which works on a single bit or a byte at a time, constantly changed by key using feedback mechanisms. And it is a very important feature. So, suppose that you have been doing some work under someone, and every time that you submit it, you get a different feedback on how what could be different like this, or how could be improvement. Same thing can be said about this Steam cipher. It is a self-synchronizing Steam cipher ensuring decryption process stays in sync with the encryption process by recognizing where it sits in the bit key system. You can also signify that how you are going to deliver your presentation and how you're going to make sure that the client or the person that you are giving the presentation to understands each and everything. Now let me tell you about block ciphers. It is a one block of fixed size data at a time. It will always encrypt a plain text data block to the same suffix when the same key is used. An example of this is a crystal cipher, which uses elements of key expansion, permutation, and substitution to create vast confusion and diffusion in cipher. So you may also be thinking why I'm discussing about this very small things about cryptography while my project creates a vast more interest in the machine learning and its cryptographical techniques. Because my this whole presentation is based on the very basics of the cryptographical technique, which will lay the not only lay the groundwork, but also be a part of the very advancement of the techniques. Now, let me show you about how the machine learning optimization will take place. So, as you can see, the maximum minima. Now, let me tell you about something that machine learning optimization, basic concepts, like all of them, are going to play a very small part or very big play part in them. I will explain you in a bit. As you can see, it is global maximum, it is a maximum value and a minimum value, respectively, on the entire domain of the function. Local minima and local maximum, it is maximum and minimum value, respectively, of the function given within range. Now, how this will be able to use in cryptography? Well, this can be used in the keys of the cryptography, in which how we going to encrypt and decrypt, in which we can not only confuse the other enemies or the other users who are trying to get to read our message, by which we can uh, create global keys and local keys using concepts like these. Also, we can also use uh, gradient descent in an optimization algorithm and found its local minima. As you can see, we can create keys like this, although it would be a very hectic job. I can explain you the technicalities of it right now, but it can change the dynamics of how we make the key, like asymmetric and symmetric keys. And the learning rate. This is a very important thing which I want to share you about. That is a hypermeter or tuning parameter that determines step size at each iteration while moving towards minima function. For example, as you can see here, the learning rate is also we can determine the key size of it and while moving towards minima in the function. Now you must be bored out of your mind, how it can be, how can we use and this. But one of the main topics is we're going to share with you now that how it's probably sums it all. By using stochastic gradient descent, we don't use all data points, but a sample of it to calculate the local minimum of the function. Strain mean probabilistic. So let uh, let me tell you this: when we encrypt our data or something, we use the known. We use the known knowledge that yeah, this is a key. We have made it using this data, and in which what I'm trying to present you is that we can also make the key using stochastic gradient descent, in which we can make key out of basically nothing, and it would be uh, it would be basically on probability, in which yes, this key has a higher chance of of being encrypted and it cannot be broken over. So yeah, we can make key as fast as it is possible over the normal traditional cryptographical techniques. It will also help determine us that how fast we are making the key, how strong the key is, and how much time will it take to decrypt by someone else. And basically, we can make a public key and private key out of it very much easily, and a symmetric key out of it will be much more powerful than the key and the private key. Now, let me move towards the cryptographical techniques. Now, there are most commonly used cryptographic techniques which are symmetric key, asymmetric key, hashing, sharing digital signatures, cryptography, quantum cryptography, stenography, zero knowledge proof, homographic encryption. Now, let me tell you about the asymmetric and the most important of them is the quantum cryptography, which I want to share with you. Seems like it is not here, but aside from that, I can tell you about it more than anyways. The symmetric key works on a system where we have encrypted and decrypted the message using the same key, which is using as symmetry. Asymmetric key is a function in which we encrypt using the public key and we decrypt using a private key, which cannot be shared in with the others. And I can tell you about quantum cryptography, in which I can tell you very much easily, is the method that uses natural occurring properties of quantum mechanics, secure and transmit data that cannot be hacked. Now you must be thinking how quantum mechanics topic in physics cannot be how is been using in this. The particles in the can a particle in the quantum mechanics can exist more than one place and a state at the time. A quantum property cannot be solved without changing or disturbing it. Whole particles cannot be copied. Now, These properties make it impossible to measure the quantum state of an any system without disturbing the system. Now we can apply these three things in the cryptography also, in which photons are used for quantum cryptography because they offer necessities qualities needed. The behavior is well understood, and the information carriers in optical fiber cables. Now there is an example in which you can determine how it can be used. In conclusion, I want to say that yes, it is a very vast topic. Yes, it is not so much to be taken interest in because it is a uh, well dreamed idea or a well wished idea, which is too good to be true. But I can say that this idea of mine is also going to be which is going to revolutionize the industry in this, and as it's going to determine how things that we perceive in a on ice are going to be changed in a very vast way. Thank you.